There's often a bit of confusion as to whether or not protective supplementary bonding is required in a bathroom. Modern installations, of course, are very often plastic pipes, and all bathrooms now have to have protection with a 30 milliamp RCD. The requirement for whether or not it requires bonding is we need to take a measurement between a known earth and whatever it is we're not sure wants bonding or not. The regulations give us an example or a formula that we should use. Where we're using an RCD, instead of using the current which is going to cause the automatic disconnection of a circuit protective device, we use the current which is going to cause the operation of an RCD. Consequently, the formula is 50 volts divided by I delta N. Okay, so I delta N in this case for a 30 milliamp RCD is 0.03. If we divide that into 50, it gives us a value of 1,667 ohms. So the measurement we need to take really is between a known earth within the room, if possible, to whatever piece of metal we think may or may not need bonding. If the resistance between the two pieces of, or the earth and the piece of metal is less than 1,667 ohms, it doesn't need bonding. It's considered that that resistance is low enough. If it's above 1,667 ohms, then it does require bonding. The problem we've got when carrying out this type of measurement is that very often our instruments won't measure 1,667 ohms. A lot of them only go up to 99.9. If you're lucky enough to have one that measures kilo ohms, then that's fine. But if not, we have to take another approach. Guidance notes tell us that the maximum shock current that we should really permit in a bathroom, none at all really, but you know, in the event of a fault, would be 10 milliamps. And from that, we can work out our resistances between pieces of equipment to see whether or not they're an extraneous conductive part or whether they're just a piece of metal. So if I divide 230 by 10 milliamps, I'm going to end up with a value of 23,000 ohms. That's pretty difficult to measure with a normal piece of equipment. So at that point, we would have to go to an insulation resistance tester. Now, what the regulations also tell us is that from fingertip to fingertip, we have a resistance of 1,000 ohms. So we can subtract the 1,000 ohms from our 23,000 ohms, which would leave us the maximum resistance permitted between a known earth and the piece of metal which we're trying to test. That's a difficult value to measure with a normal low resistance ohm meter, so we're going to use an insulation resistance tester. Of course, the insulation resistance tester won't measure very, very accurately, but it will give us an indication. So if we measure between our known earth and the piece of metal which we're not sure wants bonding or not, if we get a value of 0.02 megohms, which is 20,000 ohms or less, then it is an extraneous conductive part and it should be bonded. If we get a value of above 0.02 megohms, then it's just a piece of metal and we can ignore it.